Hello students, welcome to Tuteetute. Today we are going to discuss about some objective questions in the heat transfer subject. Okay, come on. Next, yes, here he asks the why is the negative sign introduced in the equation of the Fourier's law of heat conduction. That is, here he is asking about this negative symbol. Why this we are going to keep this symbol, this sign. This is the Fourier's equation. Q is equals, of course, either capital Q or small q depending upon the total heat transfer or heat transfer per unit. Okay, K A into dt by dx. Generally we are writing like this only, but we are keeping one negative symbol here. Why this is we are keeping is nothing but in order to generally heat is transferred. Generally, if I am going to draw the here he is asking about the heat conduction. Heat conduction, how this is takes place is nothing but suppose there is a block or any wall. There is a wall. Suppose there is a wall and the heat is transferring from this side Q and the heat is transferring along the x direction, and of course I am taking this temperature as T1, this temperature as T2. Because of the heat transfer, the temperature variations will be occurred generally, because the temperature will be going to be reduced from T1 to T2. Generally T1 to T2. While it is transferring from left side to the right side, what is the distance is nothing but suppose I am taking the distance as dx. Dx is the distance, and here I am taking the area of cross section. Suppose I am taking the area of cross section as this is the area of cross section. Here I am taking this is the area of cross section. This is the area of cross section, means which is perpendicular to the heat transfer, and this is suppose A I am taking, and according to the Fourier's law of equation we are writing Q is equals to Ka dt by dx. Generally we are writing like this, where dt is equals to T2 minus T1, means final temperature minus initial temperature. If you are looking this, T1 is always greater than T2. Suppose I am writing T2 minus T1. What will happen? T2 is less than T1. Here T2 is less than T1. In order to keep the, if I am going to substitute at this position, what will happen? You are going to get a negative value. As T1 is greater than T2. But according to this one, Q is equals to what I can write? Ka into T2 minus T1 by dx, where dx is the length of this, along the length, and area of cross section is this one. And here if you are observing, T1 is greater than T2. Here if you are observing, this value will be negative. But heat transfer means it is how much heat transfer is taking place is nothing but the value cannot be negative, because the heat is transferring from one end to the another end. It cannot be negative. So in order to keep this Q value in positive, we are keeping one negative symbol here. So negative into negative will going to be positive. So in order to keep the positive value, in order to get the positive value, we are keeping the negative value in front of the K. Okay, here if you are looking the answers, because the heat transfer rate is inversely proportional to the temperature gradient. If you are looking at heat transfer rate, means this is the heat transfer rate, but here the total heat transfer. What is the difference between the heat transfer rate and heat transfer is nothing but heat transfer per unit mass or per unit time. Generally Q is equals to, we can write down that, Q is equals to, generally we are writing Q by T, means per unit time. Generally heat transfer rate, this is the heat transfer rate. Here what he is asking, he is telling inversely proportional to the temperature gradient, but generally Q is directly proportional to the temperature gradient, where temperature gradient is nothing but T. Here if you are looking at this equation, you can write down that Q is directly proportional to dt, but here has given that inversely, but it is not inversely, it is proportional. Even it is proportionality also we cannot write. And the second thing is, because the value of the thermal conductivity is negative, we cannot say the thermal conductivity may be positive, may be negative, but maximum of the values, the thermal conductivity cannot be negative only, cannot be negative, but he has given negative. So this answer, this option is also not correct, because the heat is transferred from higher temperature to the lower temperature. Because the heat is transferred from higher temperature to the lower temperature. Yes. Here if you are looking at this one, because this is the T1 higher temperature, this is the T2 lower temperature. Because the heat is transferring from higher temperature to the lower temperature, you are going to get the T2 dt value is negative. So in order to keep the Q value as positive, we are keeping the negative. That is the answer. So this is the answer. And none of the above. No. So the answer is, because the heat is transferring from higher temperature to the lower temperature, in order to be dt positive, in order to keep the dt positive, we are keeping the negative symbol in the Q. So this is the solution. Okay, fine. Next, according to the Fourier's law of heat conduction, means what is the equation? If you are going to get the conduction in the sense Q is equals to minus Ka dt by dx, general thing is, and dt is equals to T2 minus T1, where T1 is greater than T2. We have to remember this one. Yes, what he has given, the rate of heat transfer. Of course, rate of heat transfer is nothing but small q. Small q is equals to Q by A is equals to small q. Always remember, Q by A is equals to small q. So by looking at this, sorry, Q by T, so Q by T is equals to small q generally. Okay, means per unit time generally. Rate here he has given rate. Rate is nothing but the time. With respect to the time is called rate. Rate of heat transfer means Q. You can write down Q generally. Q is equals to minus Ka dt by dx. You can write down like this also, because small q and capital Q difference is nothing but per unit time generally. Per unit time. Okay. The rate of heat transfer by conduction depends upon, here this is depending upon, one is K value, second one is A value, and the third one is dt value, and the fourth one is dx value. We'll see the option. Area of cross section normal to the heat flow. Yes, here there are two areas. What are those two areas? We will see. Okay, we'll see what are those two areas. Generally conduction will take place in the solids. We know that conduction will take place in the solids. I'm just drawing a wall. I'm drawing a wall. This is the wall. Suppose this is a wall. Suppose this is a wall, and the heat is transferring from this end to this end, where temperature here T1, here the temperature will be T2, and the temperature gradient is T1 minus T2. So T1 minus T2 is the temperature gradient. Of course T2 minus T1 generally, but we are going to take T2 as greater than T2 is less than T1, but higher temperature to the lower temperature. Here if you look at this one, there are two areas will be there. Suppose I am taking A, B, C, D is one area, and another area is A dash, B dash, C dash, D dash. There are two areas. If you are looking at the A, B, C, D, this is the front side, and if you are looking at the side view, we are going to get the A dash, B dash, C dash, D dash. And whenever the heat is transferring from this end, we are going to take the area as this area we are going to take. This area we are going to take, because the heat is transferring from left end to the right end, means both the ends, both the sides. We can take the both the sides areas. This is the one area, and another area is generally we are taking this area. This is another area, A, B, C, D. If you are taking the A dash, B dash, C dash, D dash, A dash, B dash, C, D, I mean red color. If you are taking the red color, this is perpendicular to the heat flow. This is perpendicular to the heat flow. Whereas A, B, C, D is the parallel to the heat flow. The surface area is parallel to the heat flow. Then which area I have to take in the conduction is nothing but the perpendicular area. Q is equals to minus Ka dt by dx. Here A is nothing but this area. Remember that this area means which is perpendicular to the flow direction. Area perpendicular. Here you need to understand perpendicular to the heat flow. Area which is perpendicular to the heat flow, that is A dash, B dash, C dash, D dash. You need to understand this one. You need to understand this one. Where ABCD is the parallel, we cannot take. But the length, coming to the length, we need to take this one as the dx is the length. Dx is the length. You need to understand. Here, area of cross section normal to the heat flow. Normal is nothing but, yes, normal to the heat flow is nothing but A dash, B dash. Normal or perpendicular, both are same. Remember, normal or perpendicular, both are same. Yes, this is correct. The second one, temperature gradient. Temperature gradient in the sense dt. Here you can write down that simply saying from this Q is directly proportional to K, Q is directly proportional to A, Q is directly proportional to dt, and Q is directly proportional to 1 by dx or inversely proportional to dx. Here, first case is this one, is absolutely correct. Second case is temperature gradient. This is also correct. Because depends, he has given the depends, whether it is proportionality or directly proportional or inversely proportional, he has not mentioned. Even if it is, he has given about the dx also, it is also correct. Even he is giving the dx also, this is also one of the criteria. Okay, Q is inversely proportional to dx. It is also depends only. Depends in the sense whether inversely proportional or proportional doesn't matter. Only whether dependent or independent. Here Q is depending upon the dx also. Q is depending upon the dx also. So here he has not given any dx value. So temperature gradient also it is depending. And both A and B, yes, absolutely. None of the above, no. So answer is this one, A and B. Both A and B is the answer, because from this equation you can write down that Q is directly proportional to A, Q is directly proportional to dt. Of course, Q is also directly proportional to K also, and Q is inversely proportional to dx. The thermal conductivity is expressed as, we'll see. Q is equals to, thermal conductivity. Whenever the thermal conductivity comes into picture, we should understand that K value will be thermal conductivity is nothing but K, and it will be coming in the only conduction. So Q is equals to, you can write down minus Ka dt by dx, where dt is nothing but T2 minus T1. Always remember, where T1 is greater than T2 or T2 is less than T1. Just remember this one. And he has asking the units of expressed in terms of or expressed as an, means he is asking the units for K. We'll see. Q is nothing but generally watt. Generally Q is nothing but watt, which is equals to K into area units is meter square into dt. dt is nothing but the temperature gradient, means the variation in the temperature. T1 minus T2 or T2 minus T1 means 180 degrees centigrade minus 100 degrees centigrade, 2000 degrees centigrade minus 100 degrees centigrade. Likewise, means it is in the terms of degree centigrade, or we are taking in terms of Kelvin. Okay, by dx. Dx in the sense the length. We have seen dx. Dx is the from here to here the length. So if you are we are taking this one, K value is in terms of watt. I'm taking this to this side, watt into meter by meter square into Kelvin. Don't confuse, Kelvin is capital letter, I am writing, small letter is in the thermal conductivity. Now meter will get cancelled, the rest will be watt per meter Kelvin. Watt per meter Kelvin or meter Kelvin. Here if you are looking that watt per meter Kelvin is this one, watt per meter Kelvin, and these are not the correct answers. This is a unit. So generally we'll just I am taking this to this side. Ante. That's it. As here fins are provided on heat transferring surface in order to increase. Generally fins, where we are going to observe fins is nothing but in the surroundings to the engine, generally in the vehicles. Why we are requiring the fins is nothing but in order to increase the heat transfer rate. heat transfer rate, means per unit time the heat transfer must be increased. So in order to increase the heat transfer rate, we are going to keep the fins. Okay, how the fins will be, I mean in which mode the heat transfer taking place in the fins is nothing but there are generally we know that there are three modes of heat transfer. One is conduction, second one is convection, convection, radiation. Generally we are going to observe in the fins is nothing but conduction as well as convection, because fins are generally, suppose this is the one box, I am going to transfer the heat is developed inside the box. How I am going to keep the fin is nothing but like this. Some like blades surrounding to the engine. Likewise, some blades, small, thin, likewise, so total surrounding to the engine, we are going to keep the some fins. Whenever the fins are attached, even if it because of metal, this is the metal, yes or no? This is the metal surface. Fin is nothing but it is generally aluminum or any other material we are going to produce. Okay, because it is a metal, conduction will be going to take place generally. Conduction will be going to take place. But how the conduction will be? Suppose I am drawing another thing. Suppose I am taking a fin. Suppose a fin I am taking. This is the engine and I am going to attach one fin to the engine. And of course, how it will be like means like this. This is the one fin and this is the surface of the engine. Red color will be the surface of the engine. This is one fin and another fin will be like this. Another fin, just a minute. This is another fin. This is another fin. Likewise, the number of fins will be attached. Yes. How the conduction will be taking place? Nothing but during this one. This is the flow of the heat transfer. This is the flow of heat transfer in the conduction mode. So here dx will be this one. Area will be this one. Yes or no? Because this is the area. Fine. I think you understood. No problem. Area will be this one. Yes or no? Area will be this one or this one. Area will be this one and this is the dx. Whenever you are writing q is equals to minus ka dt by dx, where area will be very short. Whereas dx is very large. Area will be very short. Generally, area will be less and dx will be more. What happened? Q value will be increases because this is decreasing, this is increasing. So what happened? This is increasing nothing but denominator increasing and numerator decreasing nothing but Q value will be decreases. Generally, Q value will be decreases. Here, what is the question? Fins are provided the heat transferring surface in order to increase. Generally, in order to increase the heat transfer only, we are going to keep the fins. But here, if you are looking at this equation, what happened? Q is going to be reducing. But our requirement is to increase the heat transfer. But here conduction heat transfer is going to be decreases. Then how we are going to manage is nothing but there are two things. One is conduction heat transfer. One is convection heat transfer. If you are looking at the convection heat transfer, what is the equation? Newton's law of cooling or Newton's law of heat. Q is equal to HA Ts minus T infinity. Ts is nothing but the surface temperature. T infinity is nothing but the ambient temperature or atmospheric temperature. Here we are not going to change the temperature differences. Here also we are not going to changing the temperatures because the surface temperature or the whatever the product temperature will be as it is, and the ambient temperature also we are not going to change. We cannot change. And of course, the thermal conductivity of the material. This is always absolutely depending upon the material only. Thermal conductivity is absolutely depends upon the material only. Here our K A dt by dx. Here if you are observing, A is decreasing, this is increasing generally, whatever that. Okay, because short area. What happened? If you are looking at, we cannot change this one, we cannot, dt by dx. We cannot change this one. The thing is, we can change the area, we can change the area, we can change the dx value. So dx means length increases. Whenever the length is going to be increases, the heat transfer is going to be decreases. Which heat transfer? Conductive heat transfer is going to be decreases. And whenever the thermal conductivity increases, I mean the material will be changing, the thermal conductivity increases, the Q value will be changing, of course. But the thermal, in order to get the thermal conductivity more, we are going to keep the more, I mean that is costly. And area will be very short. Because the fins are made with a very thin layers, very thin. This is very thin. The area will be very thin. So area is shorting, I mean decreasing. This is increasing. The thermal conductivity, I mean conductive heat transfer, the conductive heat transfer will be decreases. Coming to the convection heat transfer, Q is equal to HA delta T. HA delta T. If you are observing, this area we are taking as the, here I am just filling. This area will be taking as the conduction heat transfer. Then what is the area is convective heat transfer is nothing but this area. The surrounding areas, all surrounding areas means whatever the contact with the atmosphere, because conduction is taking place within the solids, but convection is going to take place with the fluids, generally fluid as well as the material, I mean the solid. So here area, this is one area, this is another area, and opposite sides will be another area, this also. So there are total areas which is attached to the atmosphere is the total area we are going to consider. Means it is very large because of number of plates, or we are going to keep the number of plates or the fins. So what happened to the area? Area will be going to be increases. How the means? This is one area, this is another area, this is another area. Every area which is in contact with the atmosphere will be going to be considered in the convective heat transfer. So every area we are going to consider here, but here only which is the heat flow direction which is perpendicular to the direction, but here not perpendicular, this is parallel to the surface generally. This one, I mean the total perimeter, simply saying the total perimeter, simply this one as well as this one and the bottom one. Suppose I am taking like this area, one area, and the opposite is another area. Similarly, topmost, bottommost, front and back, total 4 areas we are going to consider, and for one fin, that is, but the number of fins will be attached to the engine. Suppose every area will be considered in the heat transfer. So we cannot change this one, because H is also depends upon the atmospheric as well as the material. So we cannot change this one, only the area is going to be changes. Whenever the area is changing is nothing but, if area is increasing, how I am going to increase is nothing but by adding the number of plates like this. This is one fin, this is another fin. So area, the topmost and the left, right as well as bottom, the total 4 areas, top, front, back as well as bottom. Every fin hand consists of 4 areas we are going to consider. Likewise, the number of fins will be attached so that the area will be going to be increases. Whenever the area will be increases, Q will be increases. Then how we are going to tell conductive heat transfer is reducing, convective heat transfer is increasing? Then how we are going to tell the total heat transfer will be increasing? Nothing but comparatively convective heat transfer, conductive heat transfer is very we can neglect this decrement. Because whatever the area is very less comparatively, this perimeter area we are going to take only this one for in the convective heat transfer. So comparatively this one will be very, very less. So we can conclude that convective heat transfer is more comparatively conductive heat transfer. So here the total conductive and convective heat transfer, how it will be nothing but convective heat transfer is increases, conductive heat transfer decreases, the total heat transfer will be going to be increases by adding the number of fins. How, what he has given, fins are provided on the heat transferring surface in order to increase the, one is heat transfer area, yes, heat transfer area. Generally Q is equals to HA delta T, HA delta T or Ts minus T infinity, Ts minus T infinity. So we cannot change this one, we cannot change this one. So in order to increase this one area, in order to increase the area only, we are taking the heat transfer area. This is the heat transfer area. And heat transfer coefficient, we cannot change the heat transfer coefficient, it is the, we cannot change, not in our hands. So this is not the, and temperature gradient, Ts is nothing but whatever the temperature of the surface, we cannot change. T infinity is the ambient temperature, so we cannot change this one also. And mechanical strength, first of all we cannot change the mechanical strength by changing any other areas, or by adding the fins. So the answer will be absolutely heat transfer area. The Fourier's law of heat conduction is expressed as, we know that QA in dt by dx. Of course sometimes he may give the minus symbol or he may not give the minus may not give the minus symbol, but remember that negative symbol is in order to keep the Q positive, in order to keep the Q positive, so we are keeping the negative symbol, but the Fourier's is nothing but Q is equals to Ka dt by dx, dt by dx. Okay, where dt is equals to, here you can write down T1 minus T2 because of, in order to keep the Q positive. Yes, here also, what is the correct formula for the rate of heat transfer Q from a surface of the body of the area A surrounding, yes, here observe, surface of a body, here the body is given and to the surrounding fluid is given. One is body and one is fluid, means how it will be. Suppose this is the body and this is the fluid, means air. This is the air, which is atmospheric air, and this is the body. This is the body. Suppose this is the body. What is the correct formula? The rate of heat transfer Q from the surface of the body. Surface. This is the surface. This is the surface. Everything will be surface of the body. Is at a temperature of Ts. This is the surface temperature will be Ts. I am writing Ts. Ts is the surface temperature and the surrounding temperature is T infinity. This is the T infinity. Surrounding will be. Generally we can write down this as Q is equal to HA delta T, means H into A into Ts minus T infinity. We will see. Q is equal to HA delta T. Here you can write down what is Q, what is K is nothing but, K is the thermal conductivity of the body, H is nothing but coefficient of convection. So the answer will be this one. Q is equal to HA delta T or Ts minus T infinity. So this is a Newton's law of cooling. Newton's law of cooling. Equation name is Newton's law of cooling, which is this one. Newton's law of cooling is nothing but Q is equal to HA delta T, Ts minus T infinity. Yes, thermal conductivity of the solid metals with rise in temperature normally. Generally things are, we are having the metals or solids. Generally I am writing the solids, liquids, gases. If we are increasing the temperature, what happened? Thermal conductivity, K value, what happened? If we are increasing the temperature, what happened to the K value is nothing but, always remember, in the solid, if you are increasing the temperature, K value will be going to be reducing. K value will be going to be reducing. What about the liquids? Liquids also the K value will be reducing. Then what about the gases? K value will be increases. Generally. So, increases no, decreases yes, absolutely this is the answer. In the solids it is going to be decreasing. Generally in the liquids also it is decreasing gases, but the gases K value will be increases. So this is not the correct, this is not the correct. Answer will be only decreases. Yes, wonderful question. Here if you look at it, this one, the ratio of Q1 to Q2 means the ratio of Q1 to Q2 means there are two heat transfers will be there from two walls. There are two walls will be there, and there are two walls. What he has given, one wall is like this and another wall is like this. There are two walls will be there, same thickness means here also dx I am taking, here also dx I am taking, the same thickness is there, having thermal conductivity is Ka, K1 and K2 suppose, and he has given that K1 is equals to 2K2, K1 is equals to 2K2 he has given, same dx I am taking, and of course he has not given, but the area also I am taking the same. We are having the some equation, one wall is like this which is K1 and another wall I am taking with another sketch, this is K2 and this is dx he has given, means the thickness, and here also dx and the area is A, here also I am taking the area as A. What he has given, one is K1 is equals to 2K2, one is K1 is equals to 2K2 he has given. Then what he is asking, Q1 to Q2 is how much, Q1 to Q2 is how much. How we are going to take, because of course in the walls generally conduction will be going to be takes place according to Fourier's law of conduction equation. Q is equals to, we know that Ka dt by dx or minus Ka dt by dx, and he has mentioned did he mention about anything about the areas? No. So I am taking the A. Did he mention about anything related to the temperature difference? No. I am taking the same. So same thickness, of course he has given the same thickness, so I am taking the thickness also same. So you can write down that Q is directly proportional to area is constant. I mean generally I can write down that Q is equals to, Q1 is equals to K1 A1 D1 dt1 by dx1. Okay, similarly Q2 is equals to, you can write down that K2 A2 d2 by dx2, and I want the ratio, so I am dividing the equation 1 with equation 2. What you are going to get here, you can write down that Q1 by Q2 is equals to, here I am writing K1 A1 dt1 by dx1 into, here by this one, and that means K2 A2 into dt2 by dx2. Instead of writing the denomination, I am just writing the numerator, because denominator to denominator is numerator. So dx1 is equal to dx2, dt2 is equal to dt1. A1 and A2 I am taking the same. So here you can write down that Q1 by Q2 is equals to, generally you can write down Q1 by Q2 is equals to K1 by K2. But he has given K1 is equals to 2K2. So Q1 by Q2 is equals to, K1 is equals to 2K2. So just I am writing 2K2 by K2. So K2 will cancel. So the remaining will be Q1 by Q2 is equals to 2. So the answer will be 2, this one. Because simply Q is directly proportional to K. So Q1 by Q2 is equals to K1 by K2. Or you can write down that Q1 by Q2 is equals to, K1 is nothing but 2K2 by K2 gets cancelled, so the remaining will be Q1 by Q2 is equals to 2. You can write down like this also directly. Okay, so the answer will be 2. Critical thickness of insulation for spheres. Here what is critical thickness of insulation is nothing but, suppose I have a sphere. Here there are two cases. One is within the sphere or within the cylinder, whatever I have, during this place, during this time, I mean during this whatever the heat transfer, this is the conduction mode. This is the conduction mode. Whereas this one is the convection mode. because it is surrounding to the atmosphere. It is atmosphere. This is surrounding to the atmosphere. If you are increasing the thickness, means if you are increasing the thickness, suppose this one I am increasing the thickness. This is I am increasing the thickness. What happened? Whether the conduction heat transfer increases or conductive heat transfer increases. Likewise, sometimes conduction heat transfer is going to be increases, sometimes convective heat transfer is increases. So in order to increase the heat transfer, we are going to whatever the thickness here we are going to provide is nothing but critical thickness of insulation. Critical thickness of insulation. Here in order to generally in the boilers or in the wires, we are going to keep some thickness insulation. We are going to keep some insulation in order to sometimes in order to store the energy, in order to stop the heat transfer. So we are taking the critical thickness of insulation. Coming to the critical thickness of insulation for spheres. Spheres, it will be 2K by H. 2K by H. Of course, how to remember means there are two things. Thickness is nothing but generally in the radius. SR in the mm. SR thickness units is meter or mm, because this is the thickness only. This is the thickness. So generally we are measuring in terms of mm or meter. So what are the units for this one? K value. K units is watt per meter Kelvin, whereas H units is watt per meter square Kelvin. Just observe. Q is equals to HA delta T. Ts minus T infinity. This is watt is equals to H, I don't know. Area is meter square. Temperature is Kelvin. So if I am going to take this one into this one, H units is watt per meter square Kelvin. Similarly, if you are writing the Q is equals to Ka dt by dx, we are going to get watt is equals to K into A units is meter square, dt units is Kelvin, by dx is meter. So if I am writing this equation, what we are going to get? Watt meter by Kelvin into meter square will be thermal conductivity units. Meter gets cancelled, so watt per meter Kelvin will be raised. So generally units is this one. Here I have written watt per H units is watt per meter square Kelvin. If you are looking at this one, 2K by H, of course K by H or H by K, we can generally confuse K by H or H by K. If you are looking at this one, K by H, I am taking K by H units is watt per meter square Kelvin, meter Kelvin, watt per meter Kelvin by watt per meter square Kelvin. Kelvin gets cancelled, watt gets cancelled, meter gets cancelled. So numerator, denominator by denominator will give you numerator. So the units is meter. So K by H units is meter. K by H units is meter. Generally this is the critical thickness of insulation for cylinder. For cylinder, the critical thickness of insulation for the cylinder is K by H, where for spheres it will be 2K by H. What is critical thickness of insulation? In order to resist the or stop the heat transfer, we are going to keep some insulation. So that insulation is nothing but critical thickness of insulation, which is 2K by H for the spheres, K by H for the cylinder, K by H for the cylinder, and 2K by H is for the spheres. The ratio of total emissive power of the body to the total emissive power of a black body at the same temperature is called. Here, emissive power of the body to the total emissive power of a black body or not. Here he has given black body. What is meant by black body? A body which, whether there are three things. Whenever the heat is reflecting or absorbing or there are three modes. Where is one is there are, suppose Q is the incident energy. There are three types of possibilities are there. One is reflection, reflection, one is absorption, and another one is transmission. Reflection, absorption, and transmission. There are three things will be present. What is that? Absorptivity, transmissibility, and reflectivity. Here what he has given, the ratio of emissive power of the body, emissive power of the body to the emissive power of the black body. What is mean by black body? If the total incident energy is transmitted, what he has given, the ratio of the total emissive power of the body to the emissive power of a black body. Here he is asking about this one, E to the EB, and S. According to there is one law, Kirchhoff law or Kirchhoff's law. Generally, E by alpha is a constant. Is a constant. E by alpha is a constant according to the Kirchhoff law. Kirchhoff's law. According to its, but we can write down that E by alpha for any body is equals to EB by alpha B. Yes or no? Because it is a constant always. Whatever the body you are taking, it is a constant. E by alpha is equals to EB by alpha B. But if you are writing, here he is asking this one. Here. E by alpha is equals to, E by alpha is equals to EB by alpha B. He is asking about the E by EB. So I am writing that E by EB is equals to alpha by alpha B. But alpha by alpha B value will be generally, what is alpha B? Alpha B for black body means alpha B is equals to 1. Yes or no? Black body, the absorptivity is equals to 1, because whatever the total incident ray will be absorbed by the black body, not it for the black body. Here I am writing for the black body. What is black body is nothing but whatever the reflectivity is equals to 0, transmissibility is equals to 0, means whatever the incident ray Q will be, how much energy will be going to be fall on the black body, the total energy will be going to be absorbed only. So it will be alpha is equals to 1. Here if you are writing alpha B is equals to 1, what you can write down from this, E by EB is equals to alpha, where alpha is the absorptivity of this any body. Here whatever the body you are going to take, that body. So the answer will be absorptivity from this. You can write according to Kirchhoff's law, E by alpha is equals to constant. So every body, whatever the body you are taking, E by alpha will be constant only. Whatever that. One I am taking, one is black body, another one is normal body. So E by alpha is the normal body and another one is this is for the black body. But I know that alpha B means absorptivity for the black body is equals to 1. Absorptivity for the black body is equals to 1. Then what happened to the rho and tau will be equals to, rho is equals to 0 and tau is equals to means for the black body there will be no reflectivity, there will be no transmissibility. Whatever the total energy or total Q, whatever the heat transfer will be only in terms of absorptivity. That is the black body. Okay. So the answer will be absorptivity from this one. Okay.